Alright, evaluate the following expressions, and let's do this exactly. The inverse sine of a given ratio. Okay, so we have the ratio, which means the value of this is going to be the angle. Now, because I'm being asked for the angle, I've got to be reminded to look in the restricted domain of inverse sine. So for sine, the angles are allowed to be between, going back to my sheet of graphs, negative pi over 2 and pi over 2. So the ratio is negative. The way to write this is that the sine of theta is negative root 3 over 2. The ratio is negative in quadrant 1 or quadrant 4 going backwards. Well, this would be quadrant 4, would be right here. It's the angle measured that way because we're required to give an angle that's negative. And this is the y divided by radius for the ratio. So this represents negative root 3, this represents 2, and so by our special triangles that's 1. That little angle in there we know from special triangles is going to be pi over 3. Okay? And because it's measured backwards, we know therefore that this is equal to negative pi over 3. Okay? So when I go inverse sine of this ratio in the calculator, remember, a given ratio has an endless number of angles, but because of the restricted domain, the calculator is going to give me the angle in the restricted domain, which is this. Okay, let's just check it out to be sure. Inverse sine of negative root 3 over 2. And we're going to get that value, which is the same as negative pi over 3. Let me just confirm that. Okay, we're going to inverse sine 3 pi over 2. Now, intuitively, this should make sense in terms of us saying, oh, well, these are just inverses of each other. My answer should just be 3 pi over 2. But we got to remember that the calculator is going to give us an angle that's in the restricted domain of sine, which again is between negative pi over 2 and pi over 2. So what I have to think about is what angle has the same ratio as the sine of pi over 2, but it is within this allowable range. So we're not allowed to talk about 3 pi over 2, which is here, but we are allowed to talk about negative pi over 2. They're the same angle, as we know. So if I change this, and remember, this is equivalent to this. And the reason I'm substituting these angles is that my output value has to be within this restricted domain. And now I should expect the answer to be negative pi over 2. So I'm going to type in this expression. Here we go. Inverse sine of the sine of negative pi over 2. Close up that bracket. Equals negative 1.57, which is negative pi over 2. Okay, a couple more examples. I want to evaluate this expression exactly. So again, just to analyze it, this would be a ratio. This would be an angle. So basically this question is to calculate the cosecant of the angle, which is represented by this expression. And this is equivalent to writing that the cosine of theta is negative 2 over 3. Now as I go to draw this, I got to remember that there is a restriction for the cosine ratio, which is between 0 and pi, if you look on your graphing sheets. So 0 to pi means that the angle could be in quadrant 1 or quadrant 2. It'll have to be in quadrant 2 because the ratio is negative. So my angle is sitting somewhere over here. And the cosine ratio is the x divided by the radius. And so if I put my radius of 3 here, my x value of negative 2, this value here, which is y, I'm going to need to know that because the cosecant ratio is the radius divided by y. And if I use Pythagoras, I can see that y will be positive, and it will be the square root of 9 minus 4. 3 squared minus negative 2 squared. So it will be root 5. And so the value of the expression above will be the radius 3 divided by root 5. Okay, so just to get a feeling for to see if this is right, let's go off to our calculator. Now I'm going to type in cosecant of this. Cosecant, remember, is 1 over sine. So if I go 1 divided by the sine of this angle, and this angle is represented as the inverse cosine of negative 2 over 3, what I should get here is the decimal equivalent to 3 over root 5. And let's just see if that is 3 over root 5. Indeed. Okay, for our final example, we're going to do a similar question, but this time with a non-specific ratio. Again, this here represents an angle. So the question here is to find the tangent of this angle, where the angle represents inverse cosine of x, which is the cosine of an angle equaling x. So because x could be positive or negative, remember the allowable ratios for x would be between negative 1 and 1. It means that our angle has to be in the restricted domain, which from our restrictions on the sheets in your package would be between 0 and pi, which means that the angle could be in quadrant 1, theta could be here, or it could be in quadrant 2, the angle would be here. Alright, we need to know the tangent of this angle, and what we know is that the cosine ratio right here is x over 1, which relates to the x coordinate, I'll do that in capital X because it's not the same as little x, divided by the radius. So right here, I've got a radius of 1, I've got an x value of x, and my y value I can calculate by Pythagoras, which would be the square root of 1 minus x squared. Okay? If we go to quadrant 2, the radius is here, which is 1. The x value here is negative, okay, keeping in mind that this is where x is negative, this is where x is negative, this is where x is 0 or positive, and so this x distance is a negative number. This radius is 1. If I calculate this, again it's the square root of 1 minus r squared, so these turn out to be the same. This distance and this distance are represented by the same expression. So when I come over to decide my tangent, which is what this question was asking for, which is the y value over the x value, I can see that in both cases it's the root of 1 minus x squared over x. And this is an algebraic expression for calculating all this. Hard to believe that that works that way. So let's just test it out and make sure. So if I were to put a ratio into here that's allowable, again the ratios can be between negative 1 and 1. Let's just put in 0.5 there. So I'm going to type in tangent of inverse cosine of 0.5, and out is going to come the tangent ratio, which is that number. I should get the same thing as if I just typed in 0.5 into this expression. So let's see if that actually happens. 1 minus 0.5 squared, jump out of the brackets, divided by 0.5, and indeed it does.